Very good morning, guys. Okay, after a long back. Okay, once again we go through all the topics. Okay, did you remember the title of our subject? Okay, antennas and wave propagation. What we will discuss so far and what we'll learn from the subject antennas and wave propagation. Okay, and what may be the subject? You have to analyze from title itself only, right? Okay, antennas and wave propagation. Actually, antennas is the one part and wave propagation another part. In antennas, we have to discuss what antenna fundamentals. What is meant by antenna? What are the characteristics of antenna? What are the properties of antenna? Okay, what are the fundamental characteristics? And what are the different types of antennas? Okay, what are the different antenna arrays? Okay, and wave propagation. Okay, that antennas and wave propagation is organized as a five or six units here. Okay, 5 units discussed with antennas, and 1 unit is a wave propagation. Okay, that 1 unit is the wave propagation. I think we discussed already the fundamentals of antenna, thin linear wave antennas and antenna arrays, right? And the latter topics are and unit 4 and unit 5 are high frequency antennas and microwave antennas. Okay, but I accept uh, those two units, 4 and 5 units, and already started that 60 unit called wave propagation. Okay, why? Because that fourth and fifth units are we discuss combinedly. That is better to understand and easy to classify, and you have a clean idea, okay, about the classified antennas. Okay, uh, that's why we discuss later. The topic we will discuss later. Okay, leave it. What we learn from the unit one? From the unit one is the antenna fundamentals. Okay, what are the antenna fundamentals? What is meant by antenna? Okay, how do we define antenna? And different ways are available to define antenna. Why? Because antenna is a piece of wire. That is the basic definition. That antenna is a piece of wire that radiates electromagnetic energy, or antenna is a transducer which converts input electrical energy to output electromagnetic wave. Okay, maybe that is used as an inverse transducer. Why? Because according to Faraday's laws of electromagnetic induction, it converts input electromagnetic wave to electrical signal. Okay, maybe that antenna is used as a temperature sensitive element. Okay, and there are a lot of possibilities to define that antenna. Okay, see here in introduction concept we discussed about that antenna fundamentals. Okay, what is meant by antenna? How do we define antenna? Okay, how that piece of wire radiates electromagnetic energy? How it is possible? Okay, that a piece of electrical wire able to radiate electromagnetic energy because of retarded potential. Okay, and a continuous acceleration retardation of electrons. Okay, and when we apply one high frequency signal to that piece of wire, that radiates, okay, their energy in the form of a, electric and magnetic combination, electric and magnetic wave. Already we see. Okay, that is called a radiation mechanism. Okay, that radiation mechanism when single wire is used and two wire. Okay, similarly dipole. Okay, already we discussed about dipole. What is the current distribution in thin wire antenna, and what are the antenna parameters? Especially from the unit one, we'll learn about antenna parameters. Okay, what are the different antenna parameters? Okay, antenna impedance or antenna resistance. Okay, antenna gain, radiation resistance. Okay, antenna efficiency, front to back ratio. Okay, radiation beam, okay, or radiation efficiency, RI, radiation intensity. Okay, polarization, in that again horizontal polarization, vertical polarization, circular polarization. Okay, in that manner we discuss almost all the antenna parameters. How many number of antenna parameters we discussed in that unit? Totally 14 parameters are there. Okay, remember that number. Okay, totally 14 parameters are there. Okay, all those parameters are detailed in discussed in detail. Okay, radiation patterns. What are the radiation patterns? Okay, electric plane. Okay, E and H planes are called radiation patterns. Okay, radiation pattern. How? What is meant by radiation pattern? Radiation pattern. Pattern is the pictorial representation. Pictorial representation of what? Radiation. That's why that is called radiation pattern. Okay, the pictorial representation of radiation of electromagnetic wave is the radiation pattern. Okay, patterns in principal planes. What is meant by principal planes? What is meant by principal planes? Principal means main planes. What are the main planes in radiated electromagnetic wave? The title itself contains the radiated electromagnetic wave. Radiated electro, E component, and magnetic, electromagnetic wave. Electric component E, magnetic component H. Okay, and a magnetic field is represented with H. Electric field is represented with E. Okay, why? Because magnetic Henry's, inductance nature. Okay, that's why E and H planes are called principal planes. Okay, the main lobe and side lobes. What is meant by main lobe and side lobe? If the radiation occurs from the antenna, okay, in which direction maximum radiation occurs? That is called a main lobe. In which direction, minimum radiation occurs? That is called side lobe. But if the number of side lobes increases, the main lobe decreases, right? And in the desired direction, maximum radiation intensity decreases. Okay, due to that side lobes. That's why that side lobes are always unnecessary. Okay, that's why in order to design an antenna to control that side lobes, okay, to reduce that number of side lobes, okay, how it is possible? Okay, that mechanism is seen in the unit 3. Okay, number of side lobes. Okay, similarly that front to back ratio. Okay, main lobe level and side lobe level, SLL, side lobe level. Okay, first side lobe level, second side lobe level, third side lobe level. Okay, already derived the expression for first side lobe level also, minus 13.3 dB. Okay, prove చేసాం కూడా. Okay, okay, that is meant by main lobe and side lobes. Okay, and beam width. What is meant by beam width? Already I told you beam width and bandwidth. Beam width. Okay, if the antenna radiates maximum energy in particular direction, okay, the relation between the directivity and beam width is, if the beam width decreases, directivity increases. Just like already I tell you. Okay, I told you the difference between torchlight and laser light. Torchlight having a wider beam width and laser light having a narrow beam width. That's why that laser light and that laser show is famous because of that property. Okay, and that is moreover that concept is known only that electronic students. Okay, relation between beam width and directivity. Okay, that is the beam width and a half power beam width. Okay, from that half power beam width, here we measure that beam width. Okay, and polarization. What is meant by polarization? Polarization is nothing but, okay, the antenna is a piece of it that radiates electromagnetic energy in desired direction. In desired direction, which component is there? In desired direction, if the desired direction electric component is there, okay, okay, in between electric and magnetic components, which one is having useful information? Is it electric component or magnetic component? Okay, obviously electric component, right? Okay, that's why that polarization is always defined with the electric component. Okay, here the polarization is simply defined as the radiation. Okay, the orientation of the electric vector. Okay, because the electric component only contains useful information. That's why the orientation of the electric vector, is stated as polarization. Okay, for suppose that orientation of electric vector is perpendicular to earth surface, that is called horizontal polarization. If it is vertical to earth surface, that is called vertical polarization. During the propagation, this electric component is varied by 90 degrees. Okay, for each wavelength. That is called a circular polarization. Okay, horizontal polarization, vertical polarization, circular polarization. If that electric component having electric and magnetic component having identical amplitudes, that is called circular. If it is non-identical, that is called elliptical. Okay, these are the different polarizations, right? uh, okay, remaining what you learn: beam width, beam area, beam efficiency, okay, radiation intensity. Okay, just go through the parameters: directivity, gain and resolution, antenna apertures, antenna efficiency or aperture efficiency, okay, effective height, and related problems. Already we discuss all these topics. Okay, just revise. Okay, that is the concept of unit 1 and unit 2. Okay, what we learn from the unit 2: thin linear wire antennas. Okay, thin linear wire antennas. Okay, thin linear wire is different from thick linear wire. Okay, maybe thick wire antennas may be non-linear, right? So here we have to define the retarded potential. Retarded potential A. Okay, retarded potential A define చేసాం. B equal to del cross A ప్రాపర్టీ నుంచి A define చేసుకుంటూ వచ్చాం. Okay, A of R comma T equal to integral of V of R comma T by, okay, 4 pi square into mu naught. Okay, that is the basic definition of the retarded potential. Okay, radiation from the small electric dipole. I just okay, here we derive the expression for that electric potential of that dipole. Like similarly, quarter wave monopole and half wave dipole. Okay, please go through that derivations. It is very important, right? Evolution of field components, how the electric and magnetic field components are derived. Okay, from that derived components, according to, okay, already we discuss in detail about that concepts. Okay, step by step. Okay, first you have to define the component and H component. Once we derive that field components, later we go for pointing theorem to find out the radiated power, right? Radiated power in the desired direction, P equal to E cross H, average power equal to 1 by T into E cross H, or P equal to 1 by 2 into E into H in the dot product point of view into some, okay, cos theta. Okay, that radiated power is derived from that pointing theorem. Similarly, if the radiated power is obtained, next we go for the radiation resistance. Okay, radiation resistance R equal to generally P equal to I square, or from that R equal to P by I square, the radiated power by I square, and how much current, okay, uh, effective current passing through that thin linear wire antenna. From that, we are able to find out radiation resistance. Similarly, how to find out beam width, similarly directivity, effective area, and effective height. Similarly, natural current distributions of the fields and patterns of thin linear wire centrified antennas. Okay, and different radiation, okay, different current distributions of that antennas, right? Next, antenna theorems. Okay, what are the antenna theorems? What are the network theorems applicable to these antennas? Which theorem? Okay, can you tell me which theorem is best applicable to that antennas to transfer maximum power? Okay, it's the maximum power transfer theorem. Okay, maximum power transfer theorem transfers maximum power from transmitting antenna to receiving antenna. That's why maximum power transfer theorem is one of the best theorem is applicable to antennas. Similarly, without the theorem, uh, without that theorem, it is not possible to transmit and receive concept. Okay, or simply what it called, not possible. Okay, uh, there is not possibility of existing that transmitting and receiving antennas having a identical characteristics, is the reciprocity theorem. Reciprocity theorem. Okay, what is the reciprocity theorem? Reciprocity theorem states that, okay, source to excitation is always constant. What? Source to excitation is always constant. Okay, that theorem must be applicable. Similarly, superposition theorem. Okay, okay, these are these theorems which are applicable for the antennas. Okay, similarly, directional characteristics. What are the important properties of what are the important properties of the antenna? Okay, that is the frequently asked question in the final examination. Okay, short answers especially. Okay, can you tell me anybody? What are the important properties of the antenna? Okay, first property is always the directional characteristics must be same. Directional characteristics must be same. Next, okay, next property. First one is directional characteristics, and the radiational directional characteristics must be same. And second one is, okay, effective heights must be identical. Okay, next one, next property and effective height, directional characteristics. Third one, maximum power transfer theorem. Same resistance area has to be maintained, right? Okay, and next one, um, theorems. Okay, theorems concept is over. Next, loop antennas, but I didn't discuss that loop antennas in that unit 2. Why? Because again that is comes under unit 4 and 5. Okay, that's why I hold that concept here. Okay, next concept is antenna arrays, unit 3. Okay, what we learn from that unit 3? Antenna arrays. What is meant by antennas? Antenna arrays. Array is nothing but a antenna array. Okay, antenna array. Antenna array is nothing but group of antenna elements. Okay, that group of antenna elements may be identical or non-identical. Okay, that group of antenna elements may be identical or unidentical. Okay, here to analyze that identical or non-identical radiational characteristics, first they consider two element array, right? Okay, first they considered okay on a two element array. Okay, for that two element array we derive the expression for that potential, right? What is the resultant radiation pattern of or resultant electric potential of a two element array? Okay, what is the purpose of that arrays? Array is the group of antenna elements used to provide desired gain in desired direction. Okay, and controllability is possible, okay, because of that arrays. Okay, moreover, why, what is the need behind that arrays is just like a multi-stage amplifier, the single stage amplifier is unable to provide sufficient gain and bandwidth. So in order to improve that gain and in order to improve that bandwidth maybe, okay, we go for the multi-stage amplifier. Just like that, here single antenna element is not sufficient to provide radiate in desired direction and in the desired distance. That's why we have to go for the concept of antenna arrays. In that already we discussed two element arrays. Okay, for the two element array, different possibilities. Okay, at the same phase, opposite phase. Okay, with the two identical antennas or unidentical antennas. Okay, there are a lot of possibilities. Okay, for that, how many? Finally, what we get? Okay, 2 lambda by d cos 2 lambda by d into cos theta. Okay, that is the expression we got. Yeah, please go through that on all possibilities. Similarly, next one is the principle of pattern multiplication. What is the necessity of this principle of pattern multiplication? Principle of pattern multiplication. Okay, the advantage of the pattern multiplication is already you know how the single antenna element having radiation pattern. Okay, the single antenna element having radiation pattern, right? Single antenna element. Single antenna element having some radiation pattern. But if we want to combine multiple antenna elements, what is the resultant change in uh, uh, radiation characteristics or radiation pattern? Okay, how do we find? Okay, for suppose if we are able to find the two element pattern, then what about four element? What about six element? What about n element n elements, antenna elements? Why? Because all those antenna elements may be identical or may not, right? Okay, and all those antennas having identical characteristics, okay, the radiation pattern is able to predict it. But if those antennas having different radiational characteristics and different radiational patterns, how it is possible? In that case, okay, it is in order to estimate the radiation pattern of that antenna, okay, and that antenna array, the principle of pattern multiplication is required. Okay, according to this pattern multiplication, and what is the basic principle behind this pattern multiplication is the resultant radiation pattern of the pattern multiplication concept is simply the product of radiation pattern of the single element into group element. Okay, and a single element radiation pattern into, okay, that group element radiation pattern. When we multiply with these two, then we are able to get uh, resultant radiation pattern easily by using the graphical method, right? Okay, that is the advantage of, just wait. Okay, that is advantage of principle of pattern multiplication. Okay, and in order to find the radiation pattern of that antenna array, okay, this is the one graphical method. Okay, next, n element uniform linear array, and when we use n number of antenna elements, all those n elements are uniform and they are linear. Okay, when we bunch those n elements, that is the n element uniform linear array, what is the characteristics? Okay, what are the characteristics of the n element uniform linear array, that is also derived. Okay, and here we define the broadside and end-fire arrays, okay, very elaborately. Okay, what is the difference between broadside array and end-fire array? Okay, broadside array and end-fire array. Broadside, the title indicates broadside. Okay, and if the applied voltage, okay, if the feeding and resultant radiation pattern both are in same base phase, that is called if the radiation occurs perpendicular to the axis of array. Okay, if the radiation occurs perpendicular to the axis of array, that is called broadside. End fire means if the radiation occurs along the axis of array, that is called end fire. Okay, okay, in mathematically or numerically, in broadside array, the resultant radiation occurs 90 degrees to the axis of the main axis of the array. It is called broadside. In end-fire array, the radiation is along the axis. And the array axis is in 0 degrees with the radiation main axis. That is called end-fire array. Okay, and end-fire array with increased directivity. Okay, and how it is possible to achieve that end-fire array with increased directivity, and derivation of their characteristics and comparison. And the next one is the concept of scanning arrays. Okay, already we discuss in detail about the scanning arrays. Similarly, directivity, okay, directivity relations and related problems. Okay, next binomial arrays. Okay, already I told in detail about binomial arrays. What is the triangular method? Okay, what triangular method to obtain what are the excitation coefficients binomial array. What are the excitation coefficients of that binomial array? Okay, similarly, effect of uniform and non-uniform amplitude distributions. Design relations already we discussed. Next one is the parasitic elements. What is meant by parasitic element? Okay, we discuss 4 or 5 classes about these parasitic elements. Parasitic elements. Okay, what are called parasitic elements? Okay, uh, and in general, the director and reflectors are called parasitic elements. And the length of the dipole is short, the length of the dipole is large. Okay, and when we place that antennas one by side by side, okay, the short length dipole increase the gain uh, in its forward direction, and reflector reflects the signal towards the director. Okay, in general, the combination of that reflector and directors, and in definition, the combination of that reflector and directors are combined called as the parasitic elements. Similarly, Yagi-Uda arrays means Yagi-Uda. Yagi-Uda is the scientist name. Yagi and Uda, these two are the scientists. They provide that Yagi-Uda antenna. Okay, that is not only single antenna. That is the combination of the parasitic elements and folded dipole. Okay, that combination is the Yagi-Uda arrays. Okay, that contains one Yagi-Uda antenna, okay, director and reflector. Okay, that is called Yagi-Uda arrays. Okay, in that what are the folded dipole characteristics? Okay, we discussed, right? Unit 4 and unit 5. Okay, okay, not yet started. And unit 6 especially wave propagation. Okay, why? Because unit 4 and unit 5 is combinedly okay, uh, take it as a single unit. Okay, why? Because it is very convenient to tabulate all the antennas, and it is very easy to remember for you also. In unit 6, wave propagation. Okay, how the wave propagated from transmitter to receiver. How the wave propagated from transmitter to receiver. Okay, what are the different hurdles exist in between wave transmitter and receiver. Okay, what are the different frequencies they are able to transmit and receive. Okay, what are the different propagation characteristics of the medium. Okay, how the wave transfer from transmitter to receiver in the free space medium, and maybe through ground surface, or maybe through uh, in between atmosphere of the transmitting and receiving antenna, maybe from sky. Yeah, there are a lot of possibilities of transferring data from one place to another place with the concept of antennas. Okay, that medium is okay, and the medium which exists between the transmitter and receiver. The medium which exists between transmitter and receiver is organized as a 3 parts as ground wave propagation, skywave propagation, and a space wave propagation. Okay, 3 propagation techniques are there. Okay, 3 propagation techniques are there. Okay, by using 3 propagation techniques, and what are the resultant electric field strength by using the ground wave propagation, skywave propagation, and space wave propagation. Again, how the space wave. Okay, is it the space means is it the particular channel? No. Okay, that is completely different ionization layers are existed, and according to the ionization layers, okay, or ion layers, again that medium is divided as a different layers as D, E, F1 and F2. Okay, again with daytime and nighttime, okay, according to the sun rays. Okay, uh, that is also daytime characteristics are quite different from nighttime characteristics. Okay, according to that characteristics, and what are the effects of that propagated signal from the transmitter, again it is organized. Okay, we will discuss in detail about that wave propagation in the next unit. Okay, I mean next class, right? So that's all about revision of that 1 2 3 units and introduction that fourth unit, sorry, that sixth unit, right? I hope you revised all those concepts. Okay, in the next class we will in detail discuss about that wave propagation characteristics of that medium, right? That's all about today's class. Okay, I will continue in the next class. Thank you.